All right, well, hello, sixth grade. Today our focus is on what we call the least common multiple, or the LCM. You'll remember in our previous class, lesson 1.4, we talked about the GCF, or the greatest common factor. Today our focus is on the LCM, which is the abbreviation or short for least common multiple. Now, just like we did yesterday with the greatest common factor, we're going to be finding the least common multiple, and we're going to be doing it in different ways. Now, remember yesterday, factors were numbers that could go into another number. Like in our example, we talked about the factors of 10. Well, 1 can evenly go into 10. 2 can evenly go into 10. 5 can evenly go into 10. And 10 itself can evenly go into 10. So 1, 2, 5, and 10 were all factors of 10. Today is multiples, and just to kind of show you an idea, if I was to say list the multiples of the number 4, I'd think, well, what numbers would show up as answers or products in the 4 times tables? And I would just start, well, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And I could go on, and I could just keep listing multiples of 4 forever and ever and ever. That's not that fun. I'm not going to do that. But that's what listing multiples are. And when we talk about the common multiples, those are when we have more than one number. We'll be working with either sets of 2 or 3. And those are where multiples have to do with you find that number as a multiple of both. Okay, like for example, let's say, for example, I had the number 8 here. Well, 8 times 1 is 8. 8 times 2 is 16. Well, I see that 8 is in both lists. I see that 16 is in both lists. So 8 and 16 are common multiples. And the least common multiple is 8. 8 is the smallest number that shows up as an answer in both the 4 and the 8 times tables. Now, Venn diagram. You'll remember we did a Venn diagram in yesterday's video, in yesterday's assignment. So once again, those beautiful circles. And here we're going to have the number 4. Here we're going to have the number 7. Now, when I want to find common multiples, because the directions are going to tell you, make a Venn diagram to find the least common multiple, and you will actually have to make a Venn diagram on your paper. So, first thing you want to do, now, some teachers might teach you different things, okay? I'm going to show you what I think is the best way, and some of you are going to be able to use some mental math shortcuts and things, but you're still going to need to go through the process of making this Venn diagram here on this part. My suggestion is the first thing you do is just think 4 times 7. Because 4 times 7 is going to give you 28. So you are guaranteed that 28 is a common multiple. So you don't need to go any bigger than 28. If there's not a common multiple that's less than 28, then 28 is going to be your least common multiple. If there is something that's less than 28, then something else will be. But you need to know that you don't need to go any higher than 28. There's no reason to go any higher than 28. So we're going to start with 7. You always start with the bigger number. All right, and you're going to go up to 28. Well, 7 times 1 is 7. Okay, and when we're listing a Venn diagram, we're going to put all the numbers up to 28. So we're going to need to put them all. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. All right, so now let's think of 4. We got to go as high as 28 again. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. And 4 times 7 is 28. All right? So now we're thinking, okay, where are my common factors? Well, I see that 28 is a common factor. That number shows up in both lists. So remember, in a Venn diagram, the numbers that show up, in this case the common multiples, they're going to go in the middle, the overlapping part of both the 4 circle and the 7 circle. So I'm going to go down this list. 21, no 21 there. 14, there's no 14 in my multiples of 4. 7, there's no 7 in my multiples of 4. So for 7, I need to include 7, 14, and 21. And then for 4, I'm going to need to include 4, 8, 12, 16, 20, and last but not least, 24. And you have created a Venn diagram to find the least common multiple of 4 and 7, which I can assure you is 28. The other way, or another way, not the other way, you can find the least common multiple, is simply just by making a list. Okay? When you make a list, once again, it is advantageous just to multiply the two numbers. In this case, your two numbers are 6 and 5. So you want to think 6 times 5. Well, 6 times 5 is 30. Okay? So what we're going to do is we're not going to go any higher than 30. And we're going to start with the biggest number. Now, why do we start with the biggest number? Because we get to 30 faster that way. If we count by bigger numbers, we have bigger intervals, we're going to get to 30 faster. Okay? So my multiples of 6, well, 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. Okay? And so then I'm going into 5. Okay? And I'm going to go, well, okay, I have to make a list. But once again, I'm not going to go any higher than 30. I'm going to stop once I get to 30. 5 times 1 is 5. 5 times 2 is 10. 5 times 3, 15. 5 times 4, 20. 5 times 5 is 25. And 5 times 6 is 30. And when you make these lists, sixth graders, you got to take them up to the number that we get. All right? You're not going to really have to get that high. And if you do get higher, then you're doing it by bigger numbers. So there's not going to be that numbers anyway. So I want to see, I see that 30 is a common factor. Okay? And let's see. This is where I can think of my rules of divisibility. And I know that if a number is divisible by 5, it ends in 5 or 0. So once again, sixth graders, I'm going to encourage you, have those rules of divisibility from lesson 1.3 out ready to go. So we have 5 here. If it ends in 0 or 5, it's divisible by 5. 6 is not divisible by 5. 12 is not divisible by 5. 18 or 24, neither of them end in either 5 or 0. They are not divisible by 5. Your least common factor is 30. Now, I'm going to pause right here before we move on, because I can sense that some of you are noticing something about these first two examples that we did. And so I'm going to play a little bit of Mythbusters. I don't know if you've ever heard of that show, but I'm going to play a little Mythbusters here and make sure that we understand something. In this one Venn diagram, we did 4 times 7 and got 28, and 28 was our least common multiple. Here we had the number 6 and 5. 6 times 5 was 30. 30 was our least common multiple. I want you to make sure you understand, 6th grade, that there is no rule that says you can multiply the numbers and that is the least common multiple. That's not true, and I don't want you to think that. Case in point, the first example we did, 4 and 8. If we did 4 times 8, we would get 32. But we found that the least common multiple was 16. So I want to make sure, 6th grade, that you understand that you cannot find the least common multiple by multiplying the two numbers together. Sometimes, depending on the two numbers that you're given, that's what will happen. Okay? But there's not a rule that says that. Do not just multiply the two numbers together and say that's the least common multiple. You actually need to go through the process to make sure you're doing it right. Okay, moving right along. Prime factorization. How can we use prime factorization to help us find the least common multiple? Well, let's start here first with 16. Make our little factor tree. Well, how can I get 16? I'm going to go with 4 times 4, I guess. There's different things we could do. We can't do 16 times 1, but we could do 8 times 2. We could also do 4 times 4. Now, 4 is not a prime number, okay, because 2 can also go into 4. And we know that 4 can be divided up as 2 times 2, which means that 4 can be divided up as 2 times 2. And sure enough, I end up with 16 equals 2 times 2 times 2 times 2. All right? Now let's go to 20, and we'll come back and talk about how we can find the least common multiple. 20, I'm going to go ahead with 5 times 4. Could also have done 10 times 2, but we'll go with 5 times 4. I like 5 times 4 because 5 is a prime number. The only numbers that can go into 5 are 1 and 5. Once again, I have 4 just like I did over here. So once again, I'm going to break 4 down into 2 times 2. And then I find that 20 equals, in prime factorization, 5 times 2 times 2. Now, how do I use these prime factorizations to figure out what the least common multiple is? So, first of all, I'm looking at what the different numbers are. Here I have a bunch of 2's. Here I have a 5 and 2's. So, my two different numbers that I'm working with are 2 and 5. And so what I'm going to do first is I'm going to circle all the 2's, okay, because on the 16, because there were more 2's over here than there were here. I'm not going to circle any 2's here because there were more 2's over here. Now there are more 5's over here. There's no 5's over here at all, so I'm going to actually circle that 5 and use that 5. And now to find the least common multiple, I'm going to take these 4 2's and this 5 and turn it into a multiplication problem. 2 times 2 times 2 times 2 times 5. Well, let's see what that equals. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 5 is 80. The least common multiple of 16 and 20 is 80. All right? Find the least common multiple of the numbers. Here we have a set of 3 numbers. All right? There's a variety of ways you could do it. You could think about using a Venn diagram, but with 3 numbers, that gets a little harder. You could think about just making a list. You could think about prime factorization, different things that you could do. Here's my recommendation. You may like another way. I'm not going to force you to do it this way. Okay? But this is what I'm thinking. Okay? So, you got 4, 5, and 18. So, this is what we're going to do. we're going to think, okay, well, I'm going to do it this way. I'm going to go 4 times 5. All right. 4 times 5 is 20. 20 times 18. So I'm going to come over here. 20 times 18. 8 times 0 is 0. 8 times 2 is 16. Put a 0 down so it all lines up with my 1. 1 times 0 is 0. 1 times 2 is 2. When I add that all together, 0, 6, and 3. I get 360. Now here I'm going to pause. And I did this on purpose because 6th grade, sometimes you've got to think, all right, and say, well, okay, 360 is a pretty big number. And that's going to take a lot of effort to figure that out, okay, what that's going to be. So I'm thinking, well, okay, that may not be the way that I want to do that. Because what I could do is start listing the factors or the multiples of 18 out to 360, then listing the multiples of 5 all the way out to 360, and then listing the multiples of 4 all the way out to 360. And that just sounds like a lot of multiples. All right, I really don't want to have to do that. So I'm going to resort to and say, okay, let's try prime factorization. Okay, let's see what happens here. Now with 4, I can break that down into 2 times 2. And I have the prime factorization. 5, well, 5 is a prime number. The only way I'm going to get 5 is 5 times 1. All right, so I've got my 2, I got my 5. Then I think about 18. Well, I'm going to break down 18 with 2 times 9. 2 is a prime number. 9 is not a prime number because I can break 9 down by doing 3 times 3. 3 is a prime number, as the only numbers that can go into both 1 and 3 are 3. So here I have 2 times 2. Here I have 5. Here I have 2 times 3 times 3. Now, once again, what are the numbers that I'm working with? Well, I see I have 2s, I have 5s, and I have 3s. I have a 2 here. So the numbers that I'm working with are 2, 5, and 3. Well, where do I have the most 2s? I have the most 2s right here because I have 2 2s here. I don't have any here, and here I only have 1. So in the problem that I'm going to do, I'm going to circle those 2 2s. Well, where do I have the most 5s? Well, I have the most 5s here. It's the only place I have 5s. No 5s here, no 5s here, but I do have a 5 there. 3s. Well, I have no 3s there, no 3s here, and I have 2 3s here. Okay, so I'm going to circle them. So now what does that leave me with? I'm going to come over here now. So that leaves me with 2 times 2 times 5 times 3 times 3. All the numbers that I've used now become part of my problem. So I'm going to come over here. 2 times 2 times 5 times 3 times 3. Well, 2 times 2 is 4. 4 times 5 is 20. 20 times 3 is 60. 60 times 3 is 180. The least common multiple of 4, 5, and 18 is 180. Much easier way to do it. And depending on the numbers that you're given, sometimes this way might be the best to multiply them together. But I kind of see I can do prime factorization with these numbers pretty easy. So sixth grade, it's things to look for. Sometimes we don't always choose the best way, but even in that situation, if you do it right, you could figure it out. Because we could have gone ahead, got 360, listed all the multiples of 18, all the way up to 360, all the multiples of 5, and all the multiples of 4, all the way up to 360. Could have looked through those lists. There would have been a lot of numbers in those lists. But we would have found that the smallest number that was in all three lists was 180. There's other numbers, okay, that may have been in two lists, but the smallest one in all three was 180. All right? Have a good day, sixth grade. We'll talk to you later.